Hi everyone. So, as you know, series and sequences are very important topics in Calculus 2. So, today we're going to be focusing on series and specifically geometric series. So, geometric series looks like this. It has this form, a summation from 1 to infinity of any constant times a ratio raised to the power of n. So this is how you should recognize it. It comes in this form. So this series converges if the ratio, absolute value of the ratio is less than 1, and it diverges if that ratio is greater than 1. To find the sum of a geometric series, we have this very beneficial formula. A over 1 minus r, where a is the first term of the series, divided by 1 minus the ratio which is found in the series. So we're going to solve a couple of examples on this topic, and hopefully I'll be covering more types of series in future videos. So we have a series over here. So over here, this is an alternating series, but we can talk about that later because it goes from positive, negative, and so on. We're given four terms over here, and we want to find the sum and whether this series converges or diverges. So we need to find two things. We need to find the ratio and we need to find the sum. So to find the ratio of a geometric series, you simply divide the second term by the first term, or any two consecutive terms. So if you divide 20 over 9 divided by 10 over 3, or 10 over 3 divided by 5, you will get the same ratio. So the ratio over here, if I do negative 10 over 3 divided by 5, I will get negative 2 over 3. I want to know whether this series converges or diverges. So I'm going to take the absolute value of this r and see if it's less than 1. 2 over 3 is definitely less than 1, so this series converges. It's as easy as that. And then to find the sum of the series, we said that the formula is a over 1 minus r. So a is simply the first term which is given over here in your series, which is 5. 1 minus the ratio, which is negative 2 over 3, so this minus becomes a plus. And then you will find that once you put this in your calculator, the sum of this series is 3. So it converges and the sum is 3. All right, so the previous problem is a form of question, but the question could come in another way. So over here we have a geometric series, and how do we know that? Is that we have the constant to the power of n. In the theorem or the definition of a geometric series, you see that this n is alone. So we kind of want the way you think about it to simplify it is that you want the exponent to be n, not 2n and definitely not 1 minus n. So what we need to do is play around with this series to simplify it and get that exact form. And we want to know whether this series converges or diverges. So we're just gonna simplify. So over here it's 2 to the power of 2n. So 2 to the power of 2 is 4. And that way we got rid of the 2, which was problematic. Another part over here that's problematic is the 3, 1 minus n. So what we can do is simply split it. So it's going to be 3 to the power of 1 and 3 to the power of minus n. Proceeding, we don't want power to the negative, so simply what we're going to do is summation 4 to the power of n. There's no problem with that. There's no problem with the 3. The negative power here simply means that this term should be in the denominator to make it positive, so it's over 3n. Over here, it's not problematic, but we want a ratio with one exponent n to know that this is the ratio. And over here, what we want is one term to the power of n, so that it could be our ratio, and a constant. So we have the constant over here, we keep it as is, the 3, and then we simply combine the 4 and the 3 and give them exponent n. Here, this goes back to the form in the definition, and it's very useful to keep this in front of you to be able to go back to it whenever you'd like. So after this, we know that 4 over 3 is now our ratio. So 4 over 3 is greater than 1. So we know that this series diverges. If a series diverges, you can't find the sum. The sum and the formula a over 1 minus r is only for geometric series that converge. All right, we're going to cover one more problem in this video, and it's similar to the last problem just for extra practice. So we need to identify our problems first. We know that this is a geometric series, but we just need to modify it so that it follows. So over here, n 8n to the power of 3, this is a problem, and this is another problem over here, but we solve one by one. So 8n over 3 is the same as saying that it's 8 1 over 3, or 8 raised to the third, which is cubic root of 8. This is 2, and then you're left with the n over here. All right, so we solved this issue, and then we come to this. So when you have a term looking like this, it's good to split it. So you're going to have a 9 to the power of 1 and 9 to the power of negative half n. Following that, we still have an issue over here. We know that 9 to the power of half is 3, and it's negative, so we want to take this term down. So what we're going to do is summation from 1 to infinity. We keep the 2n as is, there's no problem with that, as well as the 9, and then we take this down 9 to the power of half times n. So we got rid of the problem of the minus, now we just have the half left and the combination to do. So I'm going to merge these two steps, and it's going to be 2 over 3 raised to the power of n. So I just combined both of those terms and simplified the bottom one, multiplied by 9. So this is your constant and this is your ratio. 2 over 3 is less than 1. This means that the series converges. To find the sum, since it converges, you just simply apply the formula A, which is the first term, divided by 1 minus r. So how do you find the first term? You simply substitute n by 1, since it starts from 1. If the series starts from another number, then you substitute using that number. So it's basically 9 times 2 over 3 divided by 1 minus 2 over 3. And if you plug that in your calculator, the sum of your series will be 18. Thank you for watching, and please suggest further problems for future videos.